So we've talked about the breakdown of material. Now we're going to talk about the movement of the material from one place to another. Okay, that's erosion. With technical difficulties, there's something missing from the first couple of slides, so I'll just tell you what it is as we go through. The driving force behind all erosional systems, gravity. All right, so put that down wherever it is. Gravity is causing everything. The dominant agent of erosion are rivers or running water. Okay. And evidence of that is anytime you go to a stream or a river and you look on the side of it, you're going to see these rocks that look rounded, smooth. That's because they've been moved for thousands and thousands of years down the river. So they get what we call abraded. They get rubbed all around and they get shaved down and they become rounded and smooth. All right. Dominant agent of erosion in arid meaning dry, is wind. Evidence of that is rough, angular, sorted sediment. I'm going fast through this because we're going to be doing more of that later on. What we're going to really be starting with today is glaciers. Okay, glaciers are large masses of moving ice. Now, a glacier forms from here, from snow that gets squeezed together and becomes what we call firn. So anytime it snows, you go outside, you walk around, you come back a day or two, your footprints have now become ice because you squeeze that ice together. That's what the firn is. Glaciers. There are two types of glaciers, a valley glacier and a continental glacier. Now, they're both slow moving. All right. They don't move as fast as streams, obviously. Valley glacier is ones that are in the mountains and come sliding down. A continental glacier is a mass of ice that's covering an area. Now, the continental glaciers are going to move too, but it's different. Valley glaciers, think about gravity, think about the ice flowing down, just like a stream would, but at a much, much slower pace. And we'll get into why or how glaciers and ice move. Continental glacier, it's on a flat surface. But what's happening is, think of a thing of silly putty in a ball and then push your hand down on it. And that silly putty is going to squeeze out in all directions. That's what a continental glacier does. The weight above pushes on the ice below, and it'll move out in all directions. Now, as most things, being that we are scientists, we need evidence. If you look here in this picture, you see these parallel scratches. These parallel scratches are called striations, and that is an evidence that a glacier went over this rock. When the glaciers are moving, they have rocks in the bottom. Okay, they have rocks in the bottom of it. The rocks will scratch the surface of the earth or the rocks below it and cause these parallel striations. When glaciers are moving, they act just like a bulldozer. That's why I got that pretty bulldozer there. They will push everything as they go. Not only will they push it, they will carry material with them. This picture here is what we call an erratic. Notice there's nothing around for this rock to have come from. What is believed, and pretty much confirmed at this point, is that this huge rock was carried by a glacier. Glacier melted away and left this rock behind.